So yep, I'm getting ready to use that torch to do some low temperature soldering here of the Danfoss air conditioning compressor. So these are 6mm ID low pressure fittings, and this is the high pressure output side. It's a 5mm fitting. I'm an American kind of technology guy these days with the plumbing fittings. Just it's hard to get metric plumbing fittings in North America. So basically I'm using 1/4 inch OD soft copper pipe to make the initial connections to the compressor here, and all I'm doing is I sanded it down. Works out to about 6.35 millimeters. You gotta sand it down to just over 6 or around 6, and then kind of wiggle it in, and they fit. So 1/4 inch, and then the output is 3/16. It's a bit loose, but the solder will take up the gap. And then I immediately go to compression fittings, and the reason for that is then I can take the compressor out of the system as necessary. And then I've got kind of a jumble of connectors. So this is the low pressure fittings. So if I spin this off, you'll see this is the modern R134 access port, threading into basically it's what's called an Acme fitting that goes into a what the old R12. These are sort of adapters for R12, the older systems, and then I'm just going from that into MPT fittings, and then into a compression fitting. So basically, these two are common to each other. One of them can be used for charging and putting oil in the system, putting refrigerant in the system, and then the output runs off to the rest of the system. On this side here, I'm putting a T in so that I can have the high port, high pressure side. The way you charge these things, I'm no expert, but basically you want to hook up, and I've got it. I've got just a simple 2-gauge manifold. You do a vacuum test to make sure the system holds vacuum for half an hour. You balance the pressure out. Then start charging. You can charge from the low side, and then you start running the pump, and then you start looking at the differential pressure. And when it's running, you can actually use the manifold and the gauges to see whether the system is actually running correctly as well, high side, low side pressures. And then you can obviously monitor the temperature. So as I assemble this system, I'll have the receiver dryer unit to clean and dry the air and get moisture out of it. And I will also have an expansion valve that is it's another Danfoss part that basically opens and closes the orifice as the system demands cooling. So I have two ways of controlling cooling. One is obviously how fast the compressor is running. I have a variable speed compressor, and I'm actually deciding that I'm going to run it off the engine ECU. So it's going to monitor temperatures, and it's going to send signals. Effectively, it's programmable resistors. I'm just going to swap resistors through a bunch of solenoids to relays, basically, to speed up and slow this thing down, because it's basically expecting to either manage the system on its own using a temperature bulb or a fixed speed that you can use with a single programmable resistor that basically determines how much current runs through a little loop, and then that drives the motor control. So what I'm doing is saying, screw all that, I'm going to control it using the engine ECU. I'll monitor the temperatures, and I'll play with the thermal expansion valve and the temperature setting. It's adjustable, how that valve opens and closes, what temperature it tries to maintain the evaporator at. And so I'll monitor all this, and I'll see if I can tune the system in terms of where I set the set point for the expansion valve temperature, opening and closing, and how fast the pump runs depending on how much cooling demand the system is. And this is a small fraction of the BTU capability of a big car. Like a huge American car might have 20,000 BTUs of thermal capacity, and a smaller car might have 8 to 10,000. This is going to be just a couple thousand, but it's going to be used very efficiently and accurately, and hopefully a couple thousand, as long as the car's, it hasn't got a huge amount of heat in it to begin with, it hopefully will throw enough cooling into the system to keep a car cool on a hot day. So as long as it's not out in the sun baking and then you try to cool it down, it could take hours with a small compressor like this. But we'll see. We'll see how the system goes. I'm going to fire up the torch now, and I'm going to solder those connections. Well, here it is. So I've set it up. So there's my low side, low pressure charge port. And then once it's charged up and oiled and all the rest of it, that can be just left alone. And then this one is the return, and then the supply side with the high side port for monitoring and charging procedures. So anyway, I think the connections are going to hold. We'll find out. When we hook the whole system up, we'll have to pressure test it or vacuum test it and see whether or not I'm pissing in the wind here, or whether I got this thing the way I need it. Well, I got oil. It's 150 milliliters of oil in the low side, and then I'll squirt 10 or 20 in each of the condenser evaporators, and then same thing in the filter dryer. So just take my POE oil with my little syringe there and just squirt a bit in each of these things, and then I'm going to then assemble it and then run the pressure test with the gauges, or the vacuum test, and with the vacuum pump behind there, and see if it holds a vacuum. So fingers crossed that my soldering was successful. And then then wire it up, fire it up. Yeah, that'd be kind of cool. Hopefully it'll come together in the next 24 hours. Well, here we are. It's all wired up, and that sound is the vacuum pump evacuating the system. And so basically, let me just start over here. So I've got the system hooked up so that the high side comes into the condenser, and then out of the condenser into the dryer, out of there into the thermal expansion valve, into the evaporator. The evaporator sits on top of the blower motor, just so that I can keep everything outside of the car, and then it returns on the low side back to the compressor. And so when I turn off this pump, it holds vacuum. Zeros here into the vacuum position here. I'm not sure how accurate these gauges are. This thing's supposed to pull almost a full 30 inches of mercury of vacuum, but the gauges are showing it's pulling 25. But anyway, it seems to be doing okay. Actually, what I should be doing is I should be turning these things off. So it's this system here, back to the pump that's actually leaking. So let's just pull up the vacuum again, get it back up to where it needs to be. It's sort of like it shows at around 25 inches of mercury, but it's I think it's closer to 30. This is a very inexpensive manifold set. Yeah, so I should turn these off now, so that this system is try that right. Yeah, I guess I'm probably not doing that right. And then see if it holds. Now, I think I'll have to read the instructions on this. I think I should leave these open to do the leak down test. Anyway, the system is looking good. There's a lot of connectors, and there's a lot of places where you can have a leak. I've had to solder aluminum to brass here to get these this is standard automotive O-ring fittings, and everything else I've been using compression fittings and NPT, national pipe thread, where you use Teflon tape and all that stuff. So either compression fittings or the NPTs, they're pretty good. I was just worried about the soldering, wherever I've had to solder. So anyway, I'm going to go for some electronics because I can't charge the system without the compressor running. So I'm going to have to wire up a battery and get the compressor going as I start feeding refrigerant into the system and charging it up. So kind of getting excited here. Well, I do have a slow leak. Fixed some of them and I still haven't quite found everything. So basically I had to replace the high side service port adapter. The other one was leaking like a sieve. I may have damaged it because I was threading it into an old R12, like these are R12 to R134 adapters, so I was threading it into a 3/16 45 degree flare, an SAE flare, and the pin, the valve, Schrader valve pin was contacting the edge of the smaller opening in the 3/16. So you can get these things with either 1/4 inch threads on both the high side and low side, or 3/16 on the high side and 1/4 inch on the low side. So I've got both combinations, but I decided to use the smaller one, and I had to drill it out because the pin was hitting anyway. I think that's what may have damaged it. I'm not blaming the manufacturer. So anyway, so that got replaced, and then I had an O-ring that wasn't set correctly here, and so they're done now. I mean, I'm still showing 20 inches of vacuum here. It's been sitting for a couple of minutes, but it's slowly dropping, and I'll be damned. I can't hear anything. I put my ear to all the fittings and tightened them all up, and so what I'm going to do is I'm going to inject some R134 into the system, pressurizing it, and then I'll do the old soapy water on all the connections to see if I can find where I might have a problem, because it's a tiny problem, but I do want to find it. I mean, this is just a test setup, but I want to see whether or not my soldered fittings are golden or whether or not it's something else. So better to do it here than when this is all in the car. So anyway, and the way this manifold works is whether you inject the R134 in here or pull a vacuum in here, when these things are closed, the gauges are still monitoring the lines. They're just disconnected from the central manifold, that's all. So that's my brain was just a little bit soft. I'm not an air conditioning guy. I'm just learning all this stuff by watching YouTube videos. I found what I think is the culprit. Cold solder joint here. This is this aluminum to copper connection here. I'm gonna have to try it again. Well, I did solve my leak. Nothing's perfect in this world, but basically I wasn't using enough flux for this particular aluminum to copper low melting point solder, so it's nasty and gooped here. This is just a temporary thing anyway, but yeah, I'm gonna go try a different type of solder. This Harris makes one called Al-Cor, and it's highly recommended, and it's fairly low temperatures, about 800 degrees. This is 500, so I think it'll do a better job. I'm also thinking about maybe using flexible lines rather than the hard lines, but no matter, I'm charging now. I've got 30 psi on both the high and the low side as the bottle's open, and it's slowly charging. I should start running the compressor just to make sure the system is fully charging. You're supposed to run the compressor while it's charging. So I'm going to wire up the electrical right now and see if I can get this thing to start flowing. And yeah, so we're making some progress here. It's good. Well, I've mounted it outside just because I was having some leaks and I didn't really want to have to fill a house full of the R134. So yeah, it's working now. I'm gonna take it back in the house though, just because it's so cold outside. It's I guess 7 degrees, 6 degrees Celsius out here. So you can see it's getting frosty here. This is actually below freezing. Here I've got maybe the superheat turned up a bit too much on this thing here. So this is cold. And this is warm. It's not like boiling hot. It's definitely radiating heat. So this is about 90 degrees Fahrenheit coming out of the out of the compressor, and then it's 0 Celsius or about 30 degrees. Actually, I have my gun right here. Let's see what it says. So it's less than freezing. It's it's -2 or -2C, about 29 degrees Fahrenheit. So you really don't want the this to be too much below 0. It'll just frost up, right? So I have to adjust the superheat on this thing. There's a screw here that adjusts what the differential temperature is across there. So yeah, the system is working. I still have leaks. It turns out the POE, the polyester oil that you use to lubricate these systems, attacks the PTFE, like the Teflon tape. So I'm using the yellow sort of gas grade stuff. I don't know if it's going to hold or not, but there's probably better ways for me to seal these lines up. Anyway, I'm learning, but yeah, so the system is functional. I've got, because it's cold outside, you don't have much pressure on the high side. It's sort of like, I think, 2.2 times the ambient temperature in Fahrenheit, so only about 50 degrees Fahrenheit outside, or even less, in the mid-40s. So my high side is running 120 psi, 115. Then my low side, I'm still charging it a little bit, but my low side is sitting in the low 20s. So it's kind of the way it should be, I think. Bring it in the house and see how it functions in the house when it's warmer ambient temperatures. Well, I'm in the house where it's 70 degrees Fahrenheit now, and it's running much higher pressures on the sorry, you can't see the light here. It's about 175 psi on the high side and 30 on the low side, and this on the evaporator is sorry, on the condenser is 100 degrees Fahrenheit approximately, and it's in the 40 something range. I'm just playing with the superheat, trying to adjust it and seeing how much oomph I can get out of this thing. It seems a bit tepid right now, so I'm playing with it, but the basic system is functioning. It's I have a leak right here that there's not much I can do about until I take it apart and again do a little bit more soldering, but I've at least got the system up and running here, so it's good. Okay, so this screw, it has to be fully counterclockwise for maximum flow, so instructions don't really explain that very well, but I'm down to the 30s on this on the evaporator side, and then on the condenser side I'm around 90 right now. So I'm cooling that off with the fan. It drops the high side pressure down to about 120, which makes sense. The system's cooler, and I'm going to put the second fan on now so I can blow hot air on one side and cold air, and I'm also going to switch the battery since this battery is now drained. I'm running it for about an hour on that lithium battery. So I think it's going to be good. Not a massive amount of cooling power, but noticeable for sure. So here we are with an air plenum just made out of cardboard there, so I can measure the temperature differential between the air coming in and going out of the box on the evaporator. And these fans are blowing roughly the same amount as sort of a medium to medium high setting in the lower of the inside of the Mark 1 and I'm seeing roughly 7 or 8 degree Fahrenheit temperature differential between the incoming and outgoing air. I've got still, I've been fooling around with the amount of refrigerant charge, and I think I have too much in. As a matter of fact, I had to bleed some off, and then it started to work a little bit better. So I know there's some tuning here in terms of the amount of refrigerant load that should go in that's ideal in terms of how the compressor and the system wants it to be. A couple limitations of this system. I'm using these permacoil oil filters or oil coolers rather than proper evaporators and condensers, so they're far less efficient at energy transfer. There's only a 4-pass. Now these tubes internally have got like cross fins inside them, but still they don't have as much of a differential temperature drop across them as you have with the proper condenser evaporator cores that are much finer, and tons and tons of loops of tubing. So that's one of the things that's holding this system back is, I've just chosen these for simplicity, and they fit where I want to put them, and I think I pay a price of probably not having nearly the efficiency that I should have in terms of intake to external, like input to output temperature differential on either side. So this is very, very cold coming out of the thermal expansion valve, and then down here it's medium cold. So the system's working. The question is, if you're bombing along and it's 85 degrees out or 90 degrees out, which is high temperature for where I live, and the inside cabin is mid-70s, is that going to do it or not? So anyway, I think if I tune this some more, I'll probably get some more out of it. But it's a small compressor, and it's never going to be the same as a full AC system. This thing is under a couple thousand BTU of peak cooling capability if everything's ideal. So I think that's we'll see. I think it's probably worthwhile. System only weighs around 15 pounds total, 15-20 pounds with all the tubing, and keep the car a little cooler in the summer. It could be nice. So anyway, here we go. I still got to get leaks out of here too. This thing broke again, so I'm going to change to a different style connector, and I've got a little leak to sit underneath the thermal expansion valve, so got to kill all those leaks off, got to get the right amount of coolant charge, and then I'll benchmark it fully, make a few phone calls and talk to some refrigerant people about how to do things properly. So I got the rear dust shields, and they fit perfectly. I'm really lucky. So there's a little, basically almost zero gap in the back against the bolt heads, but it's in tight. And I'll just show you here. I'll flip this upside down. So the way they work is they ride, like they're loose. They go over. They're not providing like a dust seal per se. They're just sort of a shield, just like the rotor shields, which I don't use because I like to keep my rotors cool, especially when racing. So anyway, this is fine. This goes on, and when this is in all the way, it's not rubbing against the dust shield or anything. So we're good. These things work. So I'm happy. And those came out of Greece on eBay.